Dear student, in this video we will learn the concept in engineering mechanics, reaction of beam. Before going to reaction of beam, we'll first discuss what is beam. In construction, there are two different types of structure we can construct. One is load bearing structure and another is frame structure. This is the diagram of frame structure. You can see in the frame structure there is a framing of horizontal member and vertical members. Whatever load which is coming on the slab, the total load is get transferred to this horizontal member, and this horizontal member will transfer this load to this vertical member. So this horizontal member is called as beam and this vertical member is called as column. So a beam is a structural member used for bearing the loads. It is typically used for resisting the vertical load which is coming from slab. You can see this actual image of beam. In this actual image, you can see these are the beams. Now, when this RC frame is get subjected to external force, the point where this beam and column connects is called as joint. So, whenever this RC frame is get subjected to external force, this joint will have basically three deformations. One is in the horizontal direction, called as horizontal deformation. Second one is vertical deformation, and third one is rotation. So each joint is get subjected to these three basic deformation. Basically this beam is resting on supports. So we'll discuss after that the types of support. So there are three different types of support. First one is roller support, second one hinge support, and third one fixed support. Let us discuss one by one. So let us discuss first roller support. This is the symbolic representation of roller support. If you observe the roller support, it is look like a wheelbase of any vehicle. Means this roller support is only able to move this beam in the horizontal direction. But this roller support is not able to move this beam in the vertical direction because of this surface. Means surface is giving the restriction to the motion in the vertical direction. So there is a normal reaction from the surface on the support in the vertical direction, and so this is that reaction. So whenever your beam is supported on a roller support, the number of unknown reaction will be 1, which is in vertical direction. So the practical example of roller support is this roller skate. Next one is hinge support. This is the symbolic representation of hinge support. If you observe the hinge support is able to move only in the horizontal, is not able to move this beam in the x direction, not able to move this beam in the y direction. So motion in x and y direction is restricted here, but this support is able to rotate about the point. You can take the example of hinge support, this door fixation. So if you see the door fixation, our door is not able to move in the x direction, not able to move in the y direction also, but the rotation of the door is possible about the point. So there is a restriction to the motion in the x direction and in the y direction only. So there will be the normal reaction in x direction and in y direction. That is RAX and RAY. So number of unknowns at the hinge support will be 2. Hinge support is also denoted as a pin support also. Okay, you can take the practical example of hinge support, also our knee joint. So our knee can rotate, but it cannot move in X and Y direction. Third one is fixed support. This is a symbolic representation of fixed support. As its name indicates that it will give the fixation to beam. So this support is not able to move this beam in X direction, not able to move this beam in the Y direction, and not able to rotate also. So from all these three directions, there is a restriction to the motion. So there will be the normal reaction in X direction, normal reaction in Y direction, and movement for the rotation. So the number of unknowns at the fixed supports are 3. You can take the practical example of fixed support is this bracket which is fixed in the wall, footing, column footing, and this electrical pole fixed in the ground. Again, we'll discuss all these 3 support. First one is roller support. So this is a symbol of roller support, which is able to move in the only X direction, not able to move in the Y direction. So there will be the normal direction in one vertical direction. So number of unknown reaction in case of roller support is 1. Second one is pin or hinge support. This is a symbolic representation of hinge support, which is not able to move in the Y direction. So there will be the normal reaction in X direction is Rx and normal reaction in Y direction is Ry. So number of unknowns are 2. And third one is fixed support. So this fixed support is not able to move in X direction, not able to move in Y direction, and the rotation of the support is also not possible. So there will be the normal reaction in X, Rx, normal reaction in Y direction, Ry, and the third one is movement. So number of unknowns in the fixed support are 3. So after discussing the types of support, we have to discuss the types of beam. So the type is a simply supported beam. So if you see this diagram, this beam is resting on a simple support. That is, one is hinge support and another is roller support. So that beam is called as simply supported beam. Second one, if you see the second one, that is a cantilever beam. The one end of the beam is fixed here on a fixed support and another end is free. So the beam is called as cantilever beam. You can see this type of beam in the balcony portion. Second one, fixed beam. The both end of the beam is having fixed support. Then that beam is called as fixed beam. Third one, continuous beam. When the beam is continue over many supports, then that beam is called as continuous beam. Next one, overhanging beam. The beam whose one portion is simply supported and other portion is overhang, that type of beam is called as overhanging beam. So after discussing the types of beams, we'll discuss the types of load. So very first, concentrated load or point load. The unit of it is Newton or kilonewton. So let us consider one simply supported beam subjected to one load at the center. So the load which is assumed to be concentrated at the center, that load is called as concentrated or point load. Now, based on the Newton's third law, every action there is an equal and opposite reaction. So here action on the beam is this load. So support will give the support reaction in the opposite direction. We can calculate that support reaction by conditions of equilibrium. Second one, uniformly distributed load, that is UDL. The unit of this load is Newton per meter or kilonewton per meter. So this is a symbolic representation of uniformly distributed load. Or this is also a symbolic representation of uniformly distributed load. So intensity of load is throughout constant over a span of L. But for the calculation purpose, we have to convert this distributed load into a point load or single load, which we have to show at center. So how to convert this uniformly distributed load into point load? So that uniform equivalent load is equal to area of this distributed load. Means the intensity of load is W, which is acting over span L. So W into L will be the equivalent point load, and that is supposed to be concentrated at the center of the beam. So this is nothing but the conversion of uniformly distributed load into point load, means only by multiplying intensity of load into length of beam. And the last one is uniformly varying load, which is called as UVL. The unit of the load is Newton per meter or kilonewton per meter. You can see this type of load on this beam. So the intensity of load is 0 at one point and maximum at other point. Means our load intensity is varying from 0 to max, called as uniformly varying load. Then again, for the calculation purpose, we have to convert this uniformly varying load into point load, which is equal to again area of this triangular load. So how to calculate the area of this load? It's W is the intensity and L is the span of the beam. So area of this triangular load will be half into W into L, that is WL by 2, and which is supposed to be concentrated at the CG of the triangle. That is, from the base of the triangle, that load is concentrated at L by 3 distance, and from the apex of the triangle it is at a distance 2L by 3. So students, here is the video